Number 4, given our function is an exponential function, then find the f inverse if it is exists. So to make sure whether this f inverse exists or not, we just imagine the exponential function graph. So it always 1 to 1 means this function f inverse is exists. Therefore, we need to find out f inverse. So how to find out f inverse? We're using composite. F inverse will be equals to x. So the place of x will be substitute as f inverse. Then we try to move everything to the right hand side until we get f inverse. So minus 2 become plus 2. So we move it to the right hand side. It become ln for this x plus 2. So finally f inverse equals to ln x plus 2 minus 3. Then for question B, on the same axis, we need to draw this function and its inverse and state its domain and range. So start with the domain of the function where we need to draw the exponential graph. So domain of the function exponential. So exponential is not special case, it will be infinity to infinity. But for the range of the function exponential, when we close this exponential, it is positive infinity, and the value we can see up here will be negative 2. So starting with negative 2 not included, that will be your asymptote, y equals to negative 2. So this range shows us negative 2 to infinity, means the function of this exponential is going up. The graph will be going up. So whether it will shooting to the right or shooting to the left. And what we can observe here, the x here is power of the coefficient is positive, so it will be shooting to the right. Then we can start drawing. So in order to get f inverse, we need to do the reflection on y equals to x. So we have to do the function first. Our first step is drawing the function first. The asymptote fall at y equals to negative 2. So as our graph want to shoot up to the right hand side, it might pass through y-axis and x-axis. So this x-axis and y-axis, they are our intercept. We have to find out what is our intercept. Therefore, when x equals to 0, our graph here will be 0 plus 3 minus 2. So we are finding the y-intercept here. So e to the power of 3 plus 2, it is 22.09. So it will be very high already actually. So meanwhile, if we want to find this is y-intercept. Meanwhile, we want to find the x-intercept. We need to let y equals to 0. So ex plus 3 minus 2 equals to 0. We simplify this. Ex plus 3 equals to 2. So x plus 3 equals to ln 2. X equals to ln 2 minus 3. So be careful of this ln 2. Ln is for the 2 is for the ln only. Then after that only minus 3. So we get negative 2.307. So this is our x-intercept. Therefore, we can imagine that exponential graph shooting up. So it will be shoot very high because it touched y-axis at very high point. So here we have our intercept 22.09 and negative 2.309. Then only we draw our refraction. So to refract this, firstly, where your asymptote touch this refraction axis, so your graph, your vertical asymptote should be x equals to negative 2. So I have to adjust a bit because this intercept negative 2.3 is almost touch value of 2. So if we shooting out higher, then only I can get this correctly, okay? So this is y equals to negative 2. Touch this refraction axis, so refracted become vertical asymptote, x equals to negative 2 label. Then our graph here. Alright, so the graph here come nearly. So for this point, they will intersect at here. And then try to do as symmetrical as you can. So for this point, they intersect at here. So shoot up 22.09. So the echo asymptote masih lagi kat bawah sini. Then we label, don't forget to label. This is negative 2.307. This is fx. This is f inverse. Then the refraction axis pass to origin. Make sure everything is labeled, including x-axis and y-axis. So after that, you have to state the domain and range of the function and the f inverse. So the domain of f inverse, we refer to the range, which is negative 2 to infinity here. And the range of f inverse, we refer to the domain, which is negative infinity to infinity. Then we move to the question C. Show that f inverse equals to x. So we have to find f composite with f inverse. So substitute our f inverse, which is ln x plus 2 minus 3, into the function. So into the fx. So this x here will be substituted by the ln. Therefore, ln x plus 2 minus 3. This is our substitution x for the x here, and then don't forget minus 3 and minus 3, and the function here got minus 2. So as we can see, we having e ln, so this one can be cancelled. So after we cancel that, we have ln plus x plus 2 minus 3. So the function is plus 3. Alright, so this is plus 3 minus 2. So plus 3 minus 3, then plus 2 minus 2, you get x shown.